In this video, I'm going to show how to take a logo or any 2D shape that exists on a sketch plane and move it to a 3+2 angle for 5-axis cutting, and that's on any surface on a 5-axis machine. So this is a lot easier if you know where the plane is that you want to move the sketch to, but that's not usually the case when you're on a machine. You just kind of have a part, like typically a cylinder head or something like that, and you just want to do a little bit of 3+2 milling on one surface, and that's not clearly defined. So I'm going to show how to do it using the probe of the machine to get a 3-point plane and then create a toolpath on that sketch. So so our sketch here, we have the origin of it right in the center, okay, right in the center of this circle, this kind of shape here. And if I hover over it, you can see that the origin is 2 in X, 0 in Y, and 1 in Z. Not that that's really important, we're going to move that to a whole new location. And the normal is 0, 0, 1, which means straight up and down in the XY plane, just like a normal 3-axis machine. So let's go ahead and click on our working plane and bring up our plane select. And now this is if you know how much you want to move it or where you want to move it to, or if you're going to pick a plane off of say a surface on a 3D model or something like that. We don't have any of that. We're just dealing with, we have a part on the machine and we're going to try to grab a plane off of the actual machine. So for that we can click on this probe plane button, and that brings up this window right here. And this window looks somewhat similar to a 3-point plane in the headboarding software. It's a little bit different. It is similar in many ways. We have point 1, 2, and 3. We define a plane a little bit differently here because a plane is kind of defined by, conceptually is like a flat surface that exists forever, and that's how you define it in this software also. But that doesn't tell you anything about the rotation around kind of the center point of the plane. So a plane, typically in CAD/CAM software, is you have, like I said, a flat surface that exists forever, but you have a point that exists on that plane somewhere, and that's called the origin. And then you have an x-axis that's along that plane and a y-axis that's along that plane. And then the z is kind of normal or perpendicular to that plane surface. Okay, we call that the height sometimes. So, if you imagine you can take this plane and rotate it around, say, 180 degrees around the z-axis of that plane, and then your x is going to be going the negative direction, your y is going to go in the negative direction. So you can kind of orient a 2D sketch on that plane however you want, and kind of any orientation around the z-axis, and position it anywhere on that plane using the origin. Okay, that's kind of a real important concept to understand here. So the way we deal with that with probing is we pick up the first point, is usually considered to be the origin, right? So that's this point right here. And the second point is directly along the x-axis. Now that's not necessarily the x-axis of the machine. It's the x-axis of how you want your 2D sketch to be oriented on your plane, okay? And then the third point is kind of defines the y-axis, but it doesn't necessarily have to be exactly lined up perpendicular like this. So the third point's not as critical. It just kind of gives you an angle in the other direction. So let's go ahead and do that a little bit here. Now I'm not actually on a machine here, so you've got to kind of use your imagination a little bit here, but hopefully I can show the concept. So let's bring the Z up and move over. Let's just say that this sketch is oriented right now on the left side of the part, so we're going to move it over somewhere like that. Okay, and let's say we want this right here to be the origin. That's where we've taken the probe and we've moved it to the place where we want the center of this circle to be. That's where we want it to actually cut on the part. So let's go ahead and hit set current location. That takes the XYZ and puts it into this point right here for point number 1. Now point number 2, let's do this. Let's make this a little bit interesting. Let's take the X and move it over, and then take the Z and move it down a little bit. So now what that does is that kind of, if you remember where I set the origin, it was up here somewhere. So we kind of have like maybe a 30 or 45 degree angle, which eventually the B-axis is going to have to rotate to that angle. But that's just 2 of the points on the plane. Okay, so let's go ahead and hit set current location there. And now let's just move the Y a little bit in the plus direction and hit set current location there. Now you can see that it did exactly what we wanted. It picked up the center point, or the origin, where we placed that first point, and then the x-axis is going down from the origin to that second point, okay, so to this x-axis plane direction point, and you can see that red x-axis is now aligned with that kind of direction that we generated there, okay, and then the y is just sort of, you know, in that general direction for the third point. So I hope that kind of makes sense. That's a lot of information there, but yeah. So that's pretty much it. We can just go ahead and hit OK there, and now you can see that our, you know, our sketch is aligned. If we do a top view, we can see it's kind of on an angle in the B-axis there. And also keep in mind that we use tool center point control on our machine. So if you have to rotate the A or the B so you can access that flat surface of wherever you want to cut it, that's perfectly fine. It'll work just the same as if you do it in 3-axis. Okay, so let's go ahead and see what we can do here now with the toolpath. So we're pretty much done with the CAD. Just go ahead and make this a little smaller and bring up our right side over here. So over here we'll do an etch, and we're just going to pick like a chamfer tool. Okay, so now we have to tell the etch where the kind of the plane that we want to cut this on. So the A and the B have to rotate to the angle of this plane so that our tool is normal to or perpendicular to that plane there. Okay. So the way we do that is generally the working origin is just going to be wherever you set your 0. Okay. So we're not gonna change the working origin. Okay. That's an issue for a different video. So we're going to just go to working face, which determines how the A and the B axis rotate. So we click on working face, and then we're not going to select anything graphically. We're just going to click on the sketch up here because we don't want to select it. We don't really have anything graphically. We just have the sketch that we know we just set the working plane to, so we can just go ahead and click on the sketch there. Now I close this down, and if I hover over the working face, you can see that it populates the, you know, the values there, so you can see it did something. Okay, and if I click on the etch, you can see it did exactly what we wanted. Put the working face in the center of our sketch, just like our actual sketch over here. Okay, so now we can just go ahead and, you know, fill out the etch just how we normally would with any 2D sketch. Okay, so we'll just go ahead and hit change to machine, click on the outside here, and then tell it to recompile, and then we get something kind of like that. Okay, so any changes that have to be made here, like the step over or anything, now's the time to do that. And then whenever you're ready, you just hit cycle start, and you can see it changes tools just how it normally should. Let's bring this up, make this a little bit bigger here. You can see that it rotated our B to that angle. When we picked up that second point, we dropped the Z down a little bit, so it put it on that plane. Okay. Now, when we picked up that third point for our sketch plane, had we dropped the Z up or down on that third point, then that would have changed the angle across the Y axis. So then the A would have rotated here as well. So yeah. Okay, so that's pretty much it. I'll just come over here real quick and explain one or two more things. If we go back to our probe plane window, we have a couple of buttons here where we can move the plane after we've defined it. There's this first button up here that says set plane's XY origin to the probe's current location. But there's no height movement at all. So, right, so if I click on the sketch here, hit no there. So if I click on the sketch here, you can see our coordinate system. Let's just turn off our toolpath so you can see easier. So you can see our coordinate system there. Now if I say, oh, well, I didn't really want my origin right there. I wanted my origin, you know, right over here somewhere, okay? But I don't want to move the plane. The height of the plane, that you know, flat surface that exists forever and infinity, that is at the right location. The height is okay. I just want to move the origin, the center point of it, and I don't want to actually have to bring the z-axis down and get that height exactly right. So that's what this button does. This will not allow that plane to move up and down at all. It just moves the origin to the closest location of where the tool is. Okay. So we're going to go ahead and click that and see what it does. You can see it moved from there to there, but the height plane is the same. Okay, so that's kind of nice. And the exact opposite of that is if you want to move the Z height up and down, but leave the origin in the same location on that plane. Okay, so might take a little bit of experimenting with to understand what both of these do, but they can be really handy, especially this top one here, right? So yeah, I guess that's pretty much it. Thanks.